Alright, when we're doing these trinomials, you'll notice this one has a 3 as its leading coefficient. That is the coefficient on the leading term. This cannot normally be done with this particular technique. This needs to have 1 times x squared plus bx plus c. So I couldn't find two numbers whose product is 90 and whose sum, or negative 90 and whose sum is negative 21. That wouldn't work here for me to do that. Instead, what I want to do is I want to start by factoring out the greatest common factor. You'll notice 3 is a common factor between these three numbers, but that's not all. There's actually a u between each of them also. So I'll start by factoring out 3u, leaving u squared minus 7u minus 30. And I can keep going now. This part right here inside the parentheses actually does match this form, this x squared plus bx plus c. So now I'd want to say, okay, now I want to find two numbers m and n whose product is negative 30 and whose sum is negative 7. Well, we got a product of negative 30. I could go 1 and 30, 2 and 15, 3 and 10. 4 doesn't go into it, 5 and 6. 6 has already been taken, so that's our complete list. We want the sum, or the product to be negative, so I know exactly one of these two numbers is going to be negative. And furthermore, I mean, I could you could just look through it, but that pair right here is what we're looking for. We want the 3 and the negative 10. So that has a sum of negative 7, so that means this factors, we still have the 3u out in front, but this part right here factors further as u plus 5 times u minus 6. Alright, looking at this one, looks like I have a 4 that's in common between the three terms. So when I factor a 4 out, I get m squared minus 4m minus 21. Now this part on the inside matches the correct form, the x squared plus bx plus c, so I can factor it using this technique. I want two numbers whose product is negative 21 and whose sum is negative 4. So to get 21, I could do 1 and 21. I could do 3 and 7. That's it. I want the product to be negative, so I want one of the two numbers to be negative. You can see if I throw it on the first one of these, the sum here is positive 4. And the reason for that, you know, I'm actually looking for a negative 4. So really what I should have done is I should have thrown it on this second one. Instead of throwing it on the 3, I should have thrown it on the 7. So that number, that pair right there is the pair I'm looking for. So this becomes 4 times m plus 3 times m minus 7. Now on this one, our greatest common factor is 3. Oops. Need to actually factor it out there. That's 9x plus 10. So now I'm looking for two numbers whose product is 10 and whose sum is 9. So to get a product of 10, I could go 1 and 10 or 2 and 5. Either both numbers are positive or both numbers are negative because the product is positive. Here I have a sum of 11, here I have a sum of 7. So it actually doesn't look like I can factor this part down any further. So this actually would be as far as I can go. I wouldn't say that this is prime though, because I was able to do some factoring. I was able to factor this 3 out. This part right here, this trinomial, is prime for what we're considering, but my end answer is not prime. I was able to do some factoring. And in general, when we're factoring, we go as far as is possible.